I'm going to tell you the story of my Mercedes-Benz Mustang hybrid build. Hi, I'm Darryl Frank. I'm a principal systems engineer by profession, but a petrol head at heart. I've always loved vintage and muscle cars. I built a Chrysler 383, an El Camino, a Ranchero, and restored a few. But there's something nobody mentions. Old cars are fantastic to look at, but really exhausting to actually drive. Comfort is negotiable, handling is optional, braking distances are totally theoretical. So I began wondering, could you have a classic presence with modern comfort and performance? And that question led me to one of the strangest automotive engineering rabbit holes I've ever gone down. My approach was to start with a used German luxury platform, something engineered for comfort, stability, and power. Something like a 7 Series BM, or S-Class Mercedes, or an Audi A6 or A8. Well engineered, comfortable, and very cheap secondhand. Through a friend, I got the opportunity to buy a Mercedes-Benz 380 SEC, which was described as in running condition. I found out those words should be taken with a pinch of salt. It definitely ran at some point in history. So I initially planned a mild restoration just to get the car running and driving again. But on arrival, I found the engine was seized. I found quickly that rebuilding the Mercedes-Benz V8 was financially unattractive. Around that time, the Lexus 1UZ swaps were very popular. Reliable, strong, and affordable, so that decision was made. Out came the 3.8 and in went the Lexus 4.3 V8. Here's a quick video of the startup of the Lexus V8. It sounds really great. That alone could have been the project, but scope control was definitely not clearly enforced. At the same time, I discovered a local fiberglass mold manufacturer selling Eleanor Mustang conversion panels. These parts were intended for an actual 65 to 69 Mustang, not a Mercedes-Benz coupe. Naturally, I thought, well, that should fit. I could make it fit. And I started my design journey. So the car began life as a standard 380 SEC coupe. And the transformation started by removing the front fenders, lights, and bumper, essentially clearing the canvas. Then I test fitted the fiberglass Mustang nose section. This originally arrived as 4 separate pieces, so the first task was bonding them into a single unified nose assembly before any meaningful fitting could begin. One design decision I made early was to preserve the original Mercedes-Benz bonnet geometry, hinges, latching, and alignment, to avoid unnecessary mechanical re-engineering. That meant removing the factory grille and reshaping the nose section to interface cleanly with the existing bonnet hardware, rather than altering the vehicle structure. Trial fitting of the rear fender sections revealed another issue. Visually, a single-piece adaptation couldn't respect the coupe's original body lines. So instead of forcing it, I changed the approach. The rear arches were cut to accommodate the wider wheels, and the fiberglass sections were segmented into 3 pieces to better integrate with the underlying geometry. So they followed the lines of the Mercedes-Benz more clearly. This is one of those moments when you realize the project isn't a kit installation, it's really a redesign exercise. With the wheel clearance resolved and major panels aligned, the base vehicle form began to emerge. The wheels, the nose, and the structural panel positioning all coming together. Once the structural panel layout was established, the attention shifted to finishing. I used polyurethane foam to bridge the gaps and define the geometry between the panels. And then I cut this and shaped it and refined it before covering it with body filler and sanding to produce a nice flat surface. As a bonus at this stage, we also got to repair some hail damage, which I found out was actually the reason the vehicle had been parked in the first place. The taillight cluster was modified to house the custom units, which I had made, achieving the Mustang 3-bar visual signature while still confirming with the adapted bodywork. I just removed the original Mercedes-Benz taillights. With the structural shaping complete, the composite reinforcement followed. I laminated the nose section with multiple layers of hand-laid carbon fiber. That's real carbon fiber. And then the rear fenders received a similar treatment. So I just covered them with a layer of carbon fiber over all the mods. This was partly engineering curiosity and mostly because I'd seen what happens when you try to bond fiberglass to metal. It just cracks after a little while. But the carbon fiber looked really good over the fenders. I fabricated a custom billet aluminium grille and installed the signature Eleanor driving lights, completing the front end identity. Inside, I installed diamond-stitched leather seating, digital motorcycle-derived instrument cluster, and wide rear tires, which was one of my design goals from the beginning. By now, brand purity had fully exited the project, and given the nature of the project, I decided to fit the Decepticon badges and the famous slogan, "To punish and enslave," over the side. It seemed appropriate. The finished car looked fantastic, and it sounded exactly how a Lexus V8 in something that definitely wasn't designed for should sound. But when I started driving it regularly, something interesting emerged. Despite the extra power, it still fundamentally drove like a 1984 Mercedes-Benz. It was still smooth and refined and composed, possibly too composed. So it turns out these cars have a very long final drive ratio, which means that they pull away incredibly smoothly, even with substantially more power available. The mods that my friends had done on similar Lexus swaps in different platforms were using shorter final drive ratios, giving much sharper acceleration, which was what I was looking for. Instead, mine behaved more like a Grand Tourer, very dignified and very stable. Slightly less muscle car menace than anticipated. So from an engineering perspective, it was a great reminder that performance is a system outcome. It's not just an engine specification or just saying that if you put more power in there, you're going to get the performance that you need. Powertrain integration, gearing, and vehicle philosophy all interact to define the behavior. You don't simply bolt on horsepower and expect the personality to change. The long gearing did offer one advantage though, the theoretical top speed. The car would comfortably reach over 205 kilometers per hour. And with roughly 40 kilowatts more from the modern V8, there was every reason to believe that it should go faster. So the plan formed to take it to Hoogskiepenpan, the South African desert venue used for the top speed runs, in essentially the local equivalent of the Bonneville salt flats. So we prepped the car and we were ready for the high speed runs, but unfortunately the event was cancelled that year due to rain in the desert, which felt like a particularly poetic engineering outcome. That would have been a fitting final chapter to the project. But sometimes the story ends in one step, or the story ends one step before the dramatic conclusion. So I drove the car for a while afterwards and eventually sold it to make room for the next project, which was a Porsche Cayenne Turbo. Looking back, this build wasn't about creating the perfect vehicle. It was about experimentation, integration challenges, and composite work, and seeing how far curiosity could take an idea. And occasionally discovering that automotive personalities govern far more than engine displacement. So if you enjoy unusual builds, engineering experimentation, or automotive diagnostics, like and subscribe, as I'll have more builds to tell you about. And I'd love to hear what's the strangest project you've ever encountered. See you next time.